And if people have questions, I can get them to you. All right.
All right. Awesome. Thanks for inviting me. Good to see y'all. You've seen me speak before, Eli. Normally, the way I do presentations is I like script everything out word for word because I struggle with presentations. But today I'm trying something a little bit different. So please bear with me. Doing a little more off the cuff with no script. Feel free if there's something that I say that you want to learn more about and I'm just moving past it, stop me and ask questions. I'll also have some questions for y'all at the end, and time to listen to your questions as well. Okay, so I'm going to talk a little bit about GeoJupyter, but first a little bit about me. So hi, I'm Matt. You can find me on GitHub as mfisher87. If you scan this QR code or go to the URL on this slide, all these slides are on GitHub, and you might want to do that to follow some of these links. There are going to be a lot of links in the talk. I'm a research software engineer. I work at Schmidt Center for Data Science and Environment at UC Berkeley, which is a charitably funded, open source first ecology environment center. I'm also a community engagement manager. I used to work at National Snow and Ice Data Center until about a year and a half, 2 years ago, where I was there for about 8 years working on uh, data processing, publication, visualization, pipeline development, kind of all over the like cryospheric data software engineering space. I'm also open source maintainer and contributor. JupyterGIS, which we'll talk a little bit about more, and JupyterTyler are two of the projects I've been working on a lot lately. I'm also a maintainer on Earth Access. I really love the Earth Access community. If you haven't tried it out, please go try out Earth Access for NASA data. And I also maintain several Conda Forge packages and some other miscellaneous stuff. I really love open source. I've always been a fan of open source. I did my first open source contribution in 2013, and this was to Yahoo's. It was called YQL, or maybe it still exists. It's their tool for querying stock data. And I was really excited for my first open source contribution, had this kind of expectation of like maybe building relationships with people, getting feedback and learning stuff. And my pull request did get merged. That was great, but nobody said a word to me. And I was like, you know what, if I'm going to be doing open source stuff, I want to do it a little different than that. That was kind of like my origin story in open source. I also love documentation. I think a lot about cognitive load and optimizing for cognitive load, both in documentation and tutorials, workshops, and also the way I write code. I love plants and nature. I love music and musical instruments. I play the drums, and I'm trying to learn keyboards. And I also love dogs. And that's me. So let's talk a little bit about GeoJupyter. GeoJupyter is a community. I think it's easy to mistake it for a piece of software, but this is kind of like an umbrella over a bunch of different projects. Some of them are software, some of them are educational efforts. Some of it is like exploring stuff and prototyping stuff to see what people need, and a lot of it is interviewing users. So our mission statement here on the slide is GeoJupyter is an open community-owned effort to reimagine geospatial interactive computing experiences within the Jupyter architecture to enable more people to confidently engage in geospatial data. And that's kind of intentionally a really broad umbrella, and that makes it a little hard for us to figure out what is the thing we need to do now, what's the thing we need to do next, which is why we talk a lot to users. And that's y'all, please talk to me. Something that I do want to make very clear is some of our work might appear as like competition to some other projects, like QGIS or ArcGIS. And in some ways, there's things about ArcGIS we specifically want to avoid. We want to enable more people to engage with our tools, so we do everything open source, everything's free. Um, Also, this is the intent of this effort is to not necessarily reinvent those wheels, but learn lessons from those people and make adaptations to our plans based on the modern ecosystem we're living in now. That when those projects started, things were very different. We didn't have this concept of cloud native, cloud optimized data. So building something new today is going to look a little bit different than those things. Oh yeah, and I should point out this big circle under our umbrella here, JupyterGIS. We're going to talk about that today. This is like our flagship project. It is a GIS environment, runs in your browser underneath JupyterLab. So a quick overview of our community. We're motivated by geospatial data being such an important part of everybody's life. It matters for like shipping, logistics, decision making, navigation, so many different domains of science for caring for our Earth. So some of the values that we have to try and improve, democratize the processes of working with geospatial data are real-time collaboration is really important. We're thinking like, if you're working on a Google Doc, that enables a certain type of collaboration you can't do with a Word doc where one person is typing and screen sharing and the other person is just looking over their shoulder. So what does it look like if we do this with maps or with GIS environments? Reproducibility is really important to us, especially if we can make reproducibility more of a default experience for users. Right now, the vibe that we hear from users is you have to do a lot of extra work to be reproducible, regardless of what tool you use, and you need extra expertise. Accessibility is very important. Helping people transition to new ways of working, transition to open science, transition to reproducibility is very important to us. Cloud native computing, cloud native data formats, and helping people transition to use those things is also very important. Also AI. This is, I think, an area where everybody is a little bit less confident about what's the right thing to do. So are we. So it's something we especially want to hear from you all about. But I'll talk a little bit more about AI in some future slides. Open and participatory development is also very important to us. Like I mentioned, everything is user-centered and user-led. We do interviews with users. I'll show you how to sign up for one of those later. If I forget, remind me. We care a lot about being very welcoming to enable contributions from across different domains to feel comfortable working with us and have fun working with us. We want that to be rewarding, and the Jupyter community is a great place for that. Exploring is very important. So we do prototyping. We show our prototypes to users. I'll show you a prototype later on today. We want to figure out like what is resonating with people, what's not resonating with people, and then maybe we throw that prototype away and don't do anything with it. Maybe it becomes a full project. We also care a lot about data and computational sovereignty. At the DSE, we do a lot of work with indigenous groups, and that's often a very important thing. Open source is a great way to achieve that, where you can run your GIS tooling on your own infrastructure, as opposed to more of a service model where you have a lot less control over your own data. There's a lot of people, a lot of partners involved in the process. I'm not going to list all these people, but I think it's important to mention we have a lot of different organizations involved here. So there's the DSE, BIDS, the MIST team, Jupyter Hub, Earth Access, QuantStack, DevSeed, Pangeo, 2I2C, several different educational institutions, and also some government institutions from Europe are involved in making this project happen. So let's talk about some of the projects we're doing right now. We'll start with the big one, JupyterGIS. This is just a quick screenshot overview of what you're looking at with JupyterGIS. Is Jupyter native GIS tool. So you can use it in a notebook as a widget, just like you might use other data visualization tools. But this particular tool provides you more of the power of like a full GIS environment than a traditional widget might. But you can also run it independently of notebooks. So these other three panels on the right here, we're just using the regular JupyterLab ability to like tile or tab your different panels, are three different GIS documents that are open at the same time. So we've got an earthquakes data set, a buildings data set, and we've got, I don't know what data this is, some data about Greenland. And these are all independent environments that you can interact with separately as different GIS projects. We support real-time collaboration. So this looks like multiple people using a map environment together at the same time, being able to see, just like in Google Docs, where other people's cursors are, geospatially aware. You can, just like Google Docs again, you can follow another user. So as another user is looking around on the map, you can go see what they're up to, look at their region of interest that they're working in. You can also edit the map together. So here a user is just changing a color map and the other user is seeing that reflected immediately on their end. You can do like comments in Google Docs, but spatially aware. So somebody can add an annotation that starts a little conversation thread. You can zoom over to where their annotation is and respond to it. Something we're working on right now is integration with stack catalogs. So right now we support a few stack catalogs, but our goal is to support any stack catalog and be able to, depending on the catalog, display footprints or the actual data from that catalog on the map and let you kind of look for the things that you're interested with and interact with it before adding it to your project. I'm going to do a demo of JupyterGIS in a little bit, but let's talk about a couple other things we have going on. We've developed JupyterTiler, which is it's a dynamic tile service that enables you to work with X-array data. And this data you have in your X-array data set might be referencing some online data sets over HTTP. And you can do computations on those data sets, and Xarray helps you only fetch the data that's necessary to do your computations, but it doesn't really help you with dynamically visualizing that data. So JupyterTiler is a component that sits in your Jupyter kernel and facilitates that dynamic visualization with a tile server. And ttiler is the kind of default tool that we use. Ttiler is by development seat. So here's what that looks like. It doesn't show the actual X-array data set in the notebook, but you can see the notebook tab here. Trust me, we're working with an X-array data set. We're just passing it to JupyterGIS saying, visualize this for me. And then as you zoom in, it's dynamically calculating the different resolution levels that you need to interact with your data, as opposed to a static plot, which is the more common workflow. Here's a prototype that our interns have been working on. Our interns, Benny and Isha, worked on prototyping what it looks like to make, oh, I see a hand, Eli.
I was just wondering if that data that we're seeing, is that cloud hosted data or was that the locally served?
The data that we're actually looking at on the South America flow accumulation data set. Yeah, so I don't remember off the top of my head. I have this notebook checked into GitHub and I can check later on. But what we're actually looking at is going through a locally hosted tile server that gets kind of like started up for you dynamically by JupyterTiler. Where the data originally came from, I'm less certain about. We can look at that in a little bit. Don't let me forget. Okay, so our prototype here, we're thinking about like, what does it look like if you want to work in a GUI environment and you want to reproduce the stuff that you've been doing in the GUI environment. Often this requires extra steps and it requires you to be like motivated to write reproducible data processing pipelines and to look for the affordances for that. So QGIS, for example, can generate GDAL commands for most of its processing pipeline things. I think it can also export to Python, but that Python is not as interoperable as I would like it to be. So here they just implemented like a really simple functionality where you draw a shape on the map and then you click the little floppy disk icon and that generates some code deterministically, not using an LLM, and inserts that code into the next cell, representing the exact shape that you just drew. And then you can use that in your notebook. One workflow we're imagining is like, we've just generated some code, and we don't want to use LLMs to generate the code with the I see somebody's excited about that. I want to talk to you more about this because we need some user support to show evidence that this is something we should continue working on. Um, so something we're thinking about is LLMs are great at generating code. You don't want to use LLMs to generate code that represents like a very specific piece of data that needs to be exactly right. So we're generating some code, but then what if we, at this point, introduced LLMs like, okay, I generated some code. I don't know what Shapely is. How do I use this with the rest of my notebook? Like maybe I want to do some statistics over a raster data set with the shape that I just drew. And then the LLM could come in and say, here's some generated code that integrates these different pieces. We're also thinking about what other things could work well with this workflow. And we're thinking about like in QGIS, you've got your processing toolbox. In ArcGIS, geoprocessing, I think it's also called a toolbox. And we have some of those features now, but we don't have this ability to generate code that reproduces the processing operations that you do. So if you do like a convex hull around like a place where you have tracking data for like wolves that have been tagged, you could then do a convex hull to get kind of like an estimate of what their territory is. But then how do you make that reproducible? What if we just use this same kind of workflow to generate the code for that uh, convex hull? Yeah. So some stuff we're thinking about in the future. We're using a planning process where we make what are called initiatives. I'll show you more about this in a little bit. It's all in GitHub open, so folks can comment and say like, I'm interested in this functionality, and that'll help us prioritize. One of the things I'm really especially interested in is scrolly telling. So I love this word, but it's a little bit niche. Those like New York Times stories where they have very rich interactive visualizations. And as you scroll through this story, things are happening as you move through the text. Like it could be taking you to different places on a map. One example is like if you're telling a story about a fire, you might start telling the story about how the fire started, and the map would then take you to the location of the first spark. And then maybe you want to talk about like historic buildings that were destroyed by the fire. You could kind of like, as you're telling this story, take people to the actual place. You could show them data about the burn area. You could show them imagery about pre-burn and post-burn. And you can kind of create a more compelling uh, narrative with this kind of like interactive scrolly telling experience than you can with a more static like blog post type of format. I really want to investigate what a scrolly telling authoring experience looks like with open source tools, perhaps driven by markdown authoring using a platform like Mist. We need to figure out how to fund that because it's not going to be a small amount of work and it's not going to be a one person thing. Um, we're also looking at AI, like I mentioned earlier. We've got an initiative that we're kind of like, it's in early stages, so it's very vague. We have a little prototype that Carl Bediger made, and there's a talk by Fernando Perez. I recommend checking that out. He gave it at the Colorado School of Mines about 2 weeks ago. It's about an hour long. He goes through different um, pieces of what we imagine the AI user experience could be, both like thinking about local models, what more we can do to enable models to use tools to like talk to geospatial data and allow you to ask questions about geospatial data. Um, and I should have added a couple more links here to some like projects that you can just try now by Carl Bediger. I think I might have one that I can pull up. Yeah, I'll put it in chat here. Carl has made several apps like this with different like kind of domain focuses, where you have a chat window. You can ask questions about the data. The LLM that you're talking to can change the map to take you to different areas of interest. It can like ask questions. It can query uh, a DuckDB database to like do calculations for you instead of just what you might expect with an LLM kind of guess. So like it's powered by tools that enable it to be a more useful science tool than just a text generator. We're also thinking about richer geospatial primitives for Python. There's a few different like libraries out there for working with geospatial data objects, but something we've noticed is there's kind of a gap with primitives where like how do you represent unambiguously a bounding box? And often if you're using like a library like icepix, the representation of the bounding box might be just a list of numbers with no uh, context about like what coordinate system are these numbers, what order are the numbers in. Um, so using those tools is a little bit confusing. As library authors, it's also a little bit burdensome to develop those tools to be intuitive. So what if we had something like datetime, the Python datetime built-in module, but for geospatial primitives? We're thinking about, like we mentioned earlier, doing geoprocessing stuff and generating code from those operations that can like directly be injected to notebook cells. So you can create your reproducible notebook without switching between QGIS and or ArcGIS and your notebook, and without like shelling out to GDAL commands, without things being kind of like magical incantations that you don't understand. Um, Something we're thinking about a little bit that I'm not sure the viability of is like JupyterGIS has a symbology editor, and what if we could extract that symbology editor to a dedicated component that multiple software projects could use? This feels like it's very complicated and too much work for the benefit we would get out of it. And then we're also thinking about example data sets for education. At the There's a spatial data science summit a couple of months ago where we brought together educators and researchers. We kind of like broke them into different groups, educators in one room, researchers in another room. And for the educators, something that came up is we don't know, we struggle to find example data sets that meet our teaching needs. Right now, there's a bunch of like scattered projects for doing example data sets. So like Seaborn, CartoPy, Xarray, GeoPandas, these all have like separate example data sets. They don't share resources. They have different priorities and different data sets. So if we could bring those different communities together to curate one example data sets project that can work for all those different software projects, that can also really help educators find the data that they need for their teaching goals. Okay, so now we'll do some demos and discussion. I want to start out with demoing JupyterGIS and then seeing if anybody has thoughts or questions about JupyterGIS. There's a couple ways you can start it. I've been using UV a lot. It's a very fast Python package manager, and you can start an ephemeral environment with dependencies with dash dash with. So here we're running JupyterLab with JupyterGIS and with JupyterLab dependencies. Or you can just launch JupyterGIS on the web. So on our docs site, here's our docs site. We have a little button that you can try with Jupyter Lite. And Jupyter Lite is a fully browser-based implementation of Jupyter. It looks exactly like JupyterLab once it launches, but there's no server. Everything is happening in your browser using WebAssembly, and there are kernels for different programming languages. Here we just have the Python kernel installed. And again, that's all in WebAssembly, runs in your browser, no infrastructure. So you can think of this like a Jupyter hub where you just download all of Jupyter and run it in your browser. No installing, no logging in, and it's all local. So I have a list of things I want to demo. Okay, let's start a new GIS project, and we get a blank JupyterGIS project here, nothing on the map, no layers. And I'm going to use the layer browser to find a base map layer. Uh, we've got them categorized right now by provider, but I think it might be more useful for us to move towards categorizing them by use case. So if I wanted a base map, I might click a base map tab. I'm going to go for the dark gray Esri base map. And I'm going to add, let's see, I'm going to add this chlorophyll layer. And then we'll see those data layers just show up on the map immediately without us having to know how to find them. I think there's a lot more we could do with this layer gallery. One thing we're considering is should users be able to override or extend the layer gallery? So maybe you're running a Jupyter hub where your focus is on cryosphere data and you have specific data sets you want people to be able to easily access. You could then extend this layer gallery to enable people to um, by pointing and clicking, find data that they're interested in. So just like a regular GIS environment, you've got your layers here. You can like reorder them. You can show and hide them. There we go. You've got opacity, sliders. I believe this data is coming to us colored, so I'm not going to show symbology yet. Let's hide this one and let's add a layer with some earthquakes. So we can just browse the files that are here in the Jupyter Lite environment. And with Jupyter Lite, the file system works just like Jupyter Lab if you were working on a hub. You can upload files using the upload button, and you can right click on any file to download it to your local computer. So this is earthquakes. And we just immediately see a bunch of earthquake points. They're not telling us very much. We can identify the earthquake points just like using the identify tool in like QGIS, and it's going to tell us all the different fields at this point. So this one's got a magnitude of 1.5. We've got a symbology editor, and right now I'm working off of our main branch, so there may be some bugs here, and I think if you see bugs, this is going to be the place. Um, we've adopted recently a grammar of graphics approach for symbology, which it feels a lot like, oh, thank you, Eli. This feels a lot like how you might do symbology in QGIS, but I think offers some advantages. So you add a mapping and then you choose what's the input value. You can choose a constant color or a constant number. So let's do a constant color. Let's make this white. Let's do stroke color. Right now, this is a little janky. I'm doing stroke color and circle stroke color because I don't remember which one actually does the thing. This should just be one. You can also map this to other things. So you can add as many like encodings for the color white as you want. So I could also fill it with white, but I'm just going to do stroke. Yep, and there's the bug. Okay, so I'm going to open up a project that already has some symbology stuff set up. This is the earthquakes layer. We just looked at that same earthquakes data set with different symbology set up. So for this one, we're setting the stroke width to 2. That might be what I missed. I probably needed to set stroke width. We're using the scalar input type and selecting the magnitude attribute. And then we're mapping magnitudes ranging from 3 to 9 linearly to an output range of 1 to 10. And then we're using that value that we get from 1 to 10 to determine the circle radius. And is that actually working here in this demo? Yeah, we can see that some of these circles are bigger than some of the other circles. So those are our higher magnitude ones. Separately, we have another symbology layer here. And if you guys have ideas about a different name than layer, because layer is already taken by the data layers, the idea here is you can symbolize this data in different ways, and you can control which one shows up on top of the other one. So layer 2 here is we're doing density. So we have a heat map transform that we're applying first. We're choosing a radius and a blur, and then we're choosing what field is weighting the heat map. And then for the actual mapping to the output value, we're choosing this calculated density value. We're using a color ramp. We chose Viridis, and then we're mapping that to the pixel RGB color. And separately, we're setting the pixel alpha transparency to a constant value of 0.9. So this is really flexible. We're in the process of figuring out how this works with our Python API. We have a pull request for that. Let me see if I'll link that in chat in case folks are interested. There's an ongoing discussion about design happening there that input would be valuable for. Yeah, I kind of like profile. Thanks, Kate. Uh, yeah, I'll put that on GitHub later on. Um, okay, I want to show. Let's do a computation real quick. So you can right click on a layer and select a processing operation. We're just going to do convex hull. I'll name this earthquakes convex hull. It's going to do the processing operation, take just a second, and then we're going to get our output. And this was probably not the best choice. Let's do buffer because that will be more visible. We can choose our distance, click OK. It's just going to run in the background. This is actually happening in WebAssembly as well. So the distance is 10 degrees of latitude or longitude, and we buffered our points. I want to show our Python API. So here's what it might look like to work with one of these documents in Python. We've got a GIS document class that you can use to open an existing document. You can also create new documents this way. So here we're just seeing in a widget a document that we can also separately open standalone. It's the exact same document. We can add a layer to that document. So here we added a Google satellite layer. What did we add? Yeah, we added a Google satellite layer and then we displayed the document again. So now we have a second widget here. And then we can add our GeoJSON, we can add an image, and this is going to update our map with all these new layers that we've added. It's interesting the zoom to layer is here twice. That's a bug that I hadn't seen before. So yeah, one of these layers here are these France regions. I want to show storytelling real quick. We've got a story editor, which let's open a different project for this. Okay, so here's our story editor. A story has been built here already. I haven't played with the story editor very much. I've been working on some other stuff. So I'm not going to try and build a story. I'll just show you the story that's been built. We've got several markers here that are like the landmarks for the story that we're going to fly between. And I'll put it in preview mode so we can do that. And this is just a tour of like some monuments. There's a little bit of text that goes along with it. And you can advance through the story with the arrow keys. That's a quick story, but this is all happening in Jupyter Lab, which I think is not the way to show stories to a broad audience. So there's this separate project called Specta, which is more of like a viewer. And we have this view mode that's specifically for story maps. You can embed this on your website, and then the story experience is, outside of Jupyter Lab, a much simpler interface that just focuses on the story, and same sort of experience where you can advance between landmarks. Something I think is really important for storytelling is that we don't constrain it to just the map geospatial data. It's really important to be able to visualize geospatial data in other ways. So you might want to take people through plots of the same data that they've just seen on the map. We don't have that right now, but that's something I really care about for the future. I think that's all I have at top of mind to show. Does anybody have questions about JupyterGIS? Any ideas come up for anybody? Tim?
Yeah, it looks like Tim has a question.
Hey, thanks very much, Matt. Really cool, inspirational stuff. So when you were going through your example where you were adding layers and changing symbology and you did a buffer, is uh, are your actions being recorded so that maybe you could go back and have that all in code? So you're basically tracking all the operations that you did, so so that you could come up with reproducible code for, say, the layers that you added and the buffer operation and maybe what your last zoom level was.
Yeah, that's something I care a lot about, but we don't have that yet. Our goal is something along the lines of the demo that I showed you earlier right now, or I wouldn't say goal. I think what we're envisioning um, something like that might look like is you go into a geoprocessing toolbox, you fill out the form, and then you click like export to notebook cell, and then you can build your notebook cell based on the operations that you want to perform that you've been able to browse through the GUI. Uh, there's a lot of complexity to that. I also think it's important to record the stuff that we're doing in the project file for provenance reasons so that like if you just get the project file and you don't get like a notebook that goes along with it, you can still see the operations that created each of the layers. But we don't have any of that stuff yet. Um, so I'm going to take a note here. Tim Haverland.
Yeah,
Um,
it's just uh yeah, it would just be really awesome to like you said, essentially record
yeah,
your operations, and then be able to reproduce that in code. So yeah, thanks. If you need somebody to talk to you about that or test some stuff out, I'm happy to be a part
amazing.
of that.
That's exactly what we need. Just taking a note here so I don't forget about that. Thank you so much, Tim. Appreciate that. It's also important that we have people that we can point to as this is a real person that wants this, so that we can prioritize things that will make a difference for real people. So thank you, Tim. Eli?
Yeah, could you talk a little more about the collaboration part? You've talked about that a few times that
Yeah.
I've seen other talks, but I still don't quite understand how that collaboration works or what
Yeah.
that
Okay.
looks like.
So the way I imagine presenting this today, because there's a little bit of complexity in setting up like an actual collaborative session, especially with a Jupyter Hub. When we have gotten collaboration working on Jupyter Hub, it was on a 2i2c hub, and we needed them to kind of like figure some of this infrastructure out, so that you could have a Jupyter Hub where instead of the hacky way to do it would be you share a password and you both log in as the same user, and then you can see the same environment and you can collaborate together. But that's not the way it should work. There is a share button here, and if you're just like running Jupyter Lab on a public HTTP server or whatever, and you have a password on it and you share the password for the Jupyter Lab, this is a way like that a research lab could share a Jupyter Lab, be able to log in and collaborate with each other. On Jupyter Lite, this isn't possible right now because you need a server to facilitate the communication between all the parties. Otherwise, you'd have to deal with complex stuff like port forwarding that like a typical user's not going to want to do. Um, there are new versions of Jupyter Collaboration that enable um, access control based collaboration. So on, I believe, Tasha Snow's CryoCloud Hub. I think this works. I haven't looked at it lately. Um, you click the share button and it gives you a menu like which users do you want to share your current session with. You click OK, you get a link you can send them, and then they can log into your shared Jupyter session, and you have this experience of being able to collaborate on the same map. Um, technically how this is all facilitated is like sending little chunks of JSON between their conflict-free replicated data types, which is something I don't understand well, but luckily we have some libraries that kind of abstract away the complexity that lets you keep these different environments in sync. And that's just exactly how Google Docs works. Was that the question you needed answered, or?
Yeah. Yeah, pretty
Yeah.
much. Yeah, just sort of hearing you talk about it more helps me understand it better.
Okay, cool. If
Um,
I had a little bit more prep time, I might have just put up like an Amazon ECS Jupyter lab that we could have all connected to and like tried it, but I was not there with everything going on over the last month.
yeah, no, I mean it's amazing seeing all this stuff. I have another question, but I'm going to wait and see if somebody else has something they would like to ask Matt.
Okay.
Yeah, anything. Now's your chance.
While we're waiting, something I should have mentioned to answer your question. We're using Jupyter Collaboration, Jupyter Collaboration. This is a
Uh-huh.
package you can install on any Jupyter lab, and it enables you to collaborate on notebooks just like Google Docs, or like collaborate on, if you use the Jupyter lab built-in editor, you can collaborate on like a Python file just like Google Docs. um, so this like fundamental building block of the Jupyter ecosystem is the same component that we depend on to enable this functionality.
Okay. Yeah, I've heard about that, but haven't used it. Well, I'll jump in and ask my other question, which is not about the GIS stuff, but this is the first time I'm seeing Jupyter Lite, and
Yeah,
this was super cool. So this is not like Bender. This isn't like it's running a server somewhere. It's not doing that, is my
correct. Yeah.
understanding.
So with Binder, Jupyter Lite, I should have also mentioned earlier, QuantStack has been kind of technically leading the Jupyter GIS work. So QuantStack is a Jupyter open source shop in Paris, France. They're all awesome. And Jupyter Lite is another one of their projects. So this is it's Jupyter. It's like actually Jupyter. That's been compiled for WebAssembly. So WebAssembly is a fairly new thing that can be a compilation target, just like compiling software for x86 processors or compiling software for Apple Silicon. You can compile to this WebAssembly target, and then you can deploy that same software in a web browser. It's just a binary blob that you download, and it runs much faster than JavaScript, and enables you to use software that you would otherwise have to completely rewrite in JavaScript. So there's lots of like Rust tooling that you can use in WebAssembly. Um, yeah, that's the general idea. Is there another question about Jupyter Lite that I can help answer?
Yeah, I guess so. Like so you're running this in Jupyter Lite, so you were able
Mhm.
to like install all the packages you need. Is that how that
Yeah,
works?
there's you can install stuff with pip and with Mamba, and this is an area where I have a little less expertise. Those packages have to already be packaged for WebAssembly, and there's a thing called mscripten forge, which in my mind this is Conda Forge for WebAssembly. Um, yeah. So if your package is packaged for mscript and forge, then you can just install it like you normally would with Mamba on your local machine, but through your Jupyter Lite, you can open a terminal here. So hold on. This actually doesn't seem to have the terminal extension installed, but you could have a notebook and you could do like, I don't know, let's try. I don't know if this is going to work. Yeah, so we can see here it's connecting to Inscript and Forge, solved the environment. Oh, and it's probably waiting for me to respond to a prompt, so I gotta do dash yes, tell it to not prompt me and just do it. Uh, is it like this? Okay, well, I don't know the invocation. In any case, you can use Mamba. I just haven't done this. I typically don't work in Jupyter Lite except for demos.
Cool. I'll have to poke around at your instance there, how you set that up, because that was super cool for me.
Good, yeah, I'm
Um,
glad you like that.
yeah.
Hmm. Yeah, not sure what I'm doing wrong.
Yeah. Tim, looks like you have another question.
Yeah. Um, Thanks. So this may be just a general question with Python and Jupyter. But is there any if you're like accessing, say, cloud-based like a cloud-based data source, or even a local data source, is there any practical limit to the size of those data sets and how much like geographic detail you can load into your map view?
Yeah, I think practically, I haven't seen limits. It depends on your data set, of course. A cloud optimized GeoTIFF, depending on the zoom level you're trying to look at this data, depending on how the data has been optimized, chunked, and uh, what levels of overviews that it has. Usually you can like very efficiently like grab a low resolution view of the whole world and then you can zoom on in on a particular block in New York City and get the very high resolution version of that data really efficiently because the data is organized in tiles in the file. And you're just like looking in the index at the top of the file to find the tiles that you care about and only downloading the data that you need to fill your screen. Um, we're also working on and maybe have merged support for ZARs, which is a little bit more robust, like data cube kind of format than GeoTIFFs, cloud optimized GeoTIFFs are. Um, I'm looking for an example here that says ZAR, and I don't see it. So this may not be merged yet. But GeoZar is kind of like the modern way to do this with really large data cubes, and we should support that soon.
What about vector data that has to be, rendered in the map itself?
Yeah, there's different ways of dealing with cloud optimized vector data. Um, I think the example, well, maybe we don't have an example for it here, so sorry in advance. Oh, PM tiles. Okay. So PM tiles is like it's a cloud optimized vector format that very similar to like a cloud optimized GeoTIFF. You can store lots of tile data. Only the data that you need is fetched, and only at the resolution that you are looking for that data at. So, as is this just regional data? Is this just New Zealand? Let's see. Yeah, this is just New Zealand data, so zooming out further isn't going to help. But we can, if like efficiently interact with the map with a large amount of data displayed because we're just using some downsampled version of it via the PM tiles format. And as we zoom in, we're getting the higher resolution version.
And the PM tiles is drawing different um, resolutions of the data at different like zoom levels. Is that the idea?
Yeah, it's you're. I think this is more complicated, or it's definitely more complicated with vector data because as you zoom really far out, like we don't need to resolve all these different features, all these different polygons. So it's both like aggregating and kind of clustering data so that it looks accurate as you zoom out, but with far fewer vertices, if that makes sense.
Yeah, yeah, yeah. Cool. I'll look into that. PM tiles. Okay, thanks.
Yeah.
Matt, looks like you've got a question in the chat.
Okay. JupyterGIS seems to be creating a lot of basic GIS functionality from scratch. Yep. More broader collaborations with established FOSS GIS communities like QGIS that could be developed. Common reusable symbology resources. Yeah, this I think that's important. We right now haven't found we haven't put into place a concrete collaboration with QGIS, but I'm really interested in a particular, acknowledging we've only got 4 minutes left here. Here's our initiatives board at GeoJupyter/initiatives. And we're thinking about, let's see, for reproducible GUI interactions that we've been talking about today. What would it look like if we built a repository of like geoprocessing operations and tools for translating those geoprocessing operations into different executors? So you could define a geoprocessing operation like buffer. We need to know what distance you want to buffer. We might want to know the coordinate reference system you want to buffer in. We want to know what target like data set or layer you want to buffer in. And then from this this data plus perhaps some templates, we could then generate the corresponding like GDAL command or Python code or JavaScript code or R code. And this is just like a big pile of data in my mind that many different projects could use that same data. For example, QGIS, they've got their geoprocessing toolbox. They're maintaining that all by themselves. That's not a shared burden with other projects. And I'm really interested in like where can we find common needs for different projects that we can bring together into one collaborative, kind of more community owned effort for that component that can be shared between many projects. Not to focus on QGIS too much, but their processing toolbox is a good example. It integrates different geoprocessing libraries in a common UI. Yeah. One thing to know about the QGIS processing toolbox is like the way they define the toolbox itself is all specific to QGIS. They're not reusing this collection of tools from another place. They are using third-party geoprocessing libraries to like execute the operations, but the definition of the operations is all specific to QGIS and not reusable. So thinking about the processing toolbox as an opportunity to create a shared component is something I care about. Also, it's unclear how we fund it, how we should prioritize it. So if this is something that particularly interests you, I'd love to talk about it more. And also this initiatives repository, it's open for comment. So if you're interested in stuff, you can do a little thumbs up on the top post on each issue, or if there are specific details you want to add in, just go ahead and add a comment. And we can also have a call and talk about this more. Let me record this too.
Yeah. All right. With that, we're at the top of the hour. I want to thank Matt again for giving us such a great presentation, overview of like a lot of really cool stuff happening. And yeah. So everyone have a great weekend. And as I said, next week we're going to be diving back into Virtualizar and some visualization examples. Next one will be a little more, little hands-on. Try to make some
Thank you
ice
all.
stuff together. All right. Take care, everyone. Thanks, Matt.
Appreciate your time
Bye.
today.
Yeah.
Bye bye.